All right, so section 4.4 is on review of inverses and exponential and logarithmic functions. So hopefully you guys remember how to take inverses. Hopefully you also remember your logarithms. If that causes fear in your heart, this is going to be a hard chapter for you because the next two sections are on logarithms. All right, so a function f is called one-to-one if it never takes the same value twice. So in other words, f of x1 is never equal to f of x2 whenever x1 is not equal to x2. So you're not going to have like the same y value. A function is one-to-one if it passes the horizontal line test. So it's a function if it passes the vertical line test. It's one-to-one if it passes the horizontal. So when a function is one-to-one, it has a unique inverse. The inverse is defined by f of x equals y if and only if f inverse of y equals x. So basically, you switch your x and y values. Remember that? So that's why you can only have one and only one y value for each x value. Because when you take the inverse, it wouldn't be a function. So that's what one-to-one means. It means the inverse is a function as well. So number one, are f of x equals x squared and g of x equals x cubed one-to-one functions? Well, think about it. X squared looks like that. X cubed looks like this. Oops, g of x. We said it's going to pass the horizontal line test. So two y values that are the same right there for different x values. So this one's a no. And this one, any horizontal line you draw through is only going to touch one and only once. So this is yes. So actually finding inverses, so it says find the inverse function of f of x equals x cubed plus 2. Do you guys remember the steps to finding the inverse? So replace the f of x with y. Then what? Switch x and y. Solve for the new y. That new y is your f inverse of x, right? So first we're going to replace the f of x with y. Then I'm going to switch my x and my y. Solve for the new y. In order to get rid of the cube root, in order to get rid of the cube, I take the cube root. So that new y value is not the same f of x that we had before. It's now f inverse of x. Okay. The nice thing about these functions is that they reflect over the line y equals x. So if you had actually graphed them, x cubed plus 2 is just the normal x cubed graph, only it's shifted up 2. So it's like that. Here's the line y equals x. So if you graph the cube root of x minus 2, it's going to look something like, this is really hard to draw, something like that. You see how they're reflected? So these are going to be equidistant here, equidistant here, equidistant here. So that's why you can always check. All right, number 3. So find the inverse function of g of x equals 4x minus 1 over 2x plus 3. This is one of the tricky ones. So I'm going to replace my g of x with y, and then I'm going to switch my x and y, so I'm going to do this in one step. So I'm going to have x equals 4y minus 1 over 2y plus 3. And I need to solve for the new y value. So back in Algebra 2, we only did one of these. I did not put this on your test. Do you guys know how to do it now? Need to solve for y. So I distribute. Most people say, oh, you just add 1, divide by 4, you have y by itself on the right side. But y is on the other side too, right? You need all the y's to be together. So what's my next step? Yeah, you can subtract the 4y over. Yeah, switch 4y and 3x. So like you're bringing the 4y over to the left side, bringing the 3x over to the right side. So that allows you to pull out the y, right? So when you do that, you can now divide by the 2x minus 4. So f inverse of x is negative 1 minus 3x all over 2x minus 4. Now, if this was a multiple choice question, they would not leave it in that form. They would. There's too many negatives. It's messy. What form would they put it in, do you think? Pull out a -1, right, Allie? Then what? Yeah, so you're going to have pull out a -1 on the top, and then I'm going to divide by a -1 on the top and bottom. So I'm going to end up with, you guys can't see it on that side of the board. I'm going to end up with f inverse of x equals 1 plus 3x, or 3x plus 1, all over, the bottom is going to be the opposite of what it was, so 4 minus 2x. Because if I pull out a -1, it's negative 2x plus 4. So 4 minus 2x, like that. That's much nicer. All right, so here's this theorem. Now, I feel like I've done a lot of multiple choice questions in the past for AP Calculus. I feel like I've done probably every multiple choice question since 1969. We have all of them. And I've only seen this pop up, I would say, once, this theorem. But I was surprised that they actually use this theorem. So it says if f is a one-to-one differentiable function with inverse function f inverse and f prime of f inverse of a is not equal to 0, then the inverse function is differentiable at a, and the derivative of the inverse function at a is 1 over f prime of f inverse of a. Ooh, that's hard. Yeah. Okay, so we're going to think about this logically. So I just said that if we have some kind of function, its inverse, so let's call that f of x, its inverse is reflected over the line y equals x, right? Like that. Something like that. All right. What it's saying is that my slope here is related to my slope here. They look kind of the same there. Don't really look the same there. Okay. So how are they related? Any guesses? Close. So the guess Victoria said was negative reciprocal. But notice both of these slopes, well, crap. Maybe I didn't draw it in the correct location. Because that is definitely supposed to be the same sign. So let me see. Okay. I don't think I drew this very well at all. Let me try it again. You guys don't have to erase, it's okay. Okay, so let me see. Where to, that would be the same. So let's say right here and right here. So let's look at those two. All right, think about how you compute the slope. So for f of x, you would do change in y over change in x, right? That would compute the slope. Oh, I didn't draw them in the right position before. I gotta think about it, because it was like, if this was 2, 4, this one needs to be 4, 2, so it'd be out further. So anyway, so if I have change in y over change in x, what is the inverse's slope? The y's and x's switch, right? So this would be x2 minus x1 over y2 minus y1. So what happens? They are just the, kind of, not opposite. That's not the word we'd use. They're the reciprocals. So slopes are reciprocals. Now what gets confusing is that what you're actually taking, it's talking about at what particular x value you're located at. So for one of them, it's f inverse of a. That's the y value from before. So this is the x value, and this is the y value that went with it. So it's telling you the x. Do you understand what I mean by that? So if this was at 2, and that was a height of 4, so that was 2, 4, this new point is going to be 4, 2. So you're not using the same x value because you've now taken the reciprocal. Or not the reciprocal, you've taken the inverse of it. All right, so let's work on it. So it says find f inverse prime of a. All right, when you look at a, it's really kind of hard to find the inverse of that, right? It would be really hard to switch your x and y and solve for y. Understand? So this is when you would need this formula. Okay. So let's think about it. Our formula, let me write it on here so we can see it. And then we'll talk about how you can know it without knowing the formula. So 1 over f prime of f inverse of a. All right. Okay, a is 4. So that means if I'm finding this, I need 1 over f prime of f inverse of 4. So when you see f inverse of 4, that's saying f of something equals 4. You're finding x. So we have a big long equation. We have 2x cubed plus 3x squared plus 7x plus 4 equals 4, right? F of x equals 4. What does x have to be? 0, thank you. They will be very simple like that. Like if this was a multiple choice question, it would be very simple. You'd be able to see what f inverse was. All right, so we're really computing 1 over f prime of 0. Can we do f prime of 0? Yeah. F prime of x is 6x squared plus 6x plus 7. So f prime of 0 is 7. So in our case, our answer is 1 over 7. Okay, if you at least know that x is 0, this will be easy. You just find f prime of 0. Take the reciprocal. That's it. Okay, so looking at this one, we know we're going to have to find when f of x is equal to 2. Because that's telling us when f inverse of 2, it's telling us what that's equal to, f inverse of 2. So in other words, we have 1 over x minus 1. When is that equal to 2? We can solve that. Easy enough. Multiply the x minus 1 over. Add the 2. So I get 3 over 2. Makes sense. 1 over 1.5 minus 1. So 1 over 1/2 is 2. All right. So what this means is that f inverse of 2 is equal to 3.2 because f of 3.2 was equal to 2. Do you guys see what I'm saying? You switch your x and y value. Okay, so it's saying 1 point was 3.22. That was in your f function. In f inverse, that means you have the opposite. You have 2, 3.2. You switch your x and y. So that means f inverse prime of a, so not a, I guess, of 2 is 1 over f prime of 3 over 2. So it's the y value that goes with 2. So we need to find f prime of x. So f prime of x is low, d high, minus high, d low, all over the square of what's below. You could have also done the chain rule. Do you guys see it? You could have thought of that as x minus 1 to the negative 1 power, and then use the chain rule. So if I'm doing f prime of 3 over 2, it's 1 over, so I plug in 3 over 2, so I get, so when I plug in 3 over 2 for x right there, I get 1/2, and I'm squaring it. I'm going to have -1 over 1/2 squared, which is -1 over 1/4, which is what? -4, right?
How can we find the derivative?
Why do you find the derivative?
Yeah.
Because you need to find, the bottom is the derivative. The derivative is the slope, right? And we were saying at those points, the slopes are reciprocals of each other. So you find the slope of your original to find the slope of the inverse. You just take the reciprocal of it. Okay, so tricky one. Like I said, not super important. It was on those multiple choice questions. I've only seen it one time. And I was like, wow, I can't believe you actually have to use this theorem that I thought no one really had to know. All right. So in your previous math classes, you learned that exponential functions have an inverse. We say that a to the y equals x if and only if y equals, do you guys remember how you would solve for this? You take log base a of a to the y equals log base a of x. So if y equals log base a of x. Okay, do you guys remember I always did like the little swoopy thing? So I'd say, here's my base. So the base of the logarithm is my base of my exponent. So a raised to the other side of the equation equals what's left. So a to the y equals x. I keep switching it. All right, so product property. So log of a times b. Maybe you remember this. You'll be my favorite Algebra 2 students ever if you remember all these. Log of a what?
Plus.
Thank you, Great Randall. Log of a plus log of b. It kind of goes with the exponents rule. Remember, if I had x to the second times x to the fifth, it was a multiplication property, but you added the exponents, similar with logarithms. Okay, log of a to the m, log base a, or log of a, right? No base. Must be log base 10. Change base formula. Log of a over log of b. Do you guys really all remember these? Good. Yay, 2 years ago. All right, question property. Oh, did you have to do it in steps? So this is log of a minus log of b. Okay, inverse properties. Log base a of a to the m is m, because log base a of a is 1, right? And the m goes to the front, so m. So we were doing our power property. So you bring the m to the front. Log base a of a is 1. All right, and then a raised to log base a of m. M. Okay, for a is greater than 1, the limit as x goes to infinity, so looking at log base 10 of x over here. Do you guys see our example? So as x goes to infinity, what is the limit of this log function? It's infinity. It gets bigger and bigger. All right, and then the limit as x goes to 0 from the right of log base a of x is negative infinity. It goes down forever. I'm already, man.